The best jigs in the workshop are simple, easy to build and reliable. And this little crosscut sled ticks all three boxes. Its diminutive size belies its true capacity, and this little guy punches way above its weight class. How's it? My name is Dylan. Welcome to my workshop, and in today's edition of Ply Creations, I'm going to show you how to make one of your own. For today's build, we are going to need a base, a fence, and lastly, you're going to need some form of a runner or a slider that we're going to be using in the miter slot. Now, this you can make from either a little piece of hardwood. One of my favorite ways to do that is to use a plastic chopping board that I chop up to size. What we are trying today is something new to me, is sliders that I found on the internet. I've printed them on my brand new 3D printer, and I'm going to try them for the first time on this particular build. That's basically what you need for building a crosscut sled that works. Anything else that you can add to that is an embellishment. I am also adding a section of plywood that I am going to be making a bit of a modification to the system, and I'll show that to you later. As far as dimensions go and materials, both the base and the fence are made from birch ply. The thickness of the ply is just less than 15 millimeters. Almost dropped the base. Just less than 15 millimeters. I think it's closer to 9/16 for you guys across the pond. And both the fence and the base, I'll be using the same material. As far as the fence goes, if you want to know how I made this, I'll leave a link on the screen and the description. I made this in my last video. Length is roughly the same length as the base that I am going to be using. Base dimension, by the way, is 570 millimeters squared. It comes to around about 22.5 inches. Its height, and width is somewhat determined by the stop hardware that I am going to be adding to the build. We'll cover that in a little bit later. I've got a T-track that's been lying around in my workshop now for years looking for a home, and I'm going to be using it on this build. Do you have to use birch ply? Absolutely not. My previous crosscut sled was simply made from a piece of, I think it's shutter ply that I had lying around in the workshop. Now, if I like my existing crosscut sled so much, why am I building a new one? Well, it is starting to show its age, 1. 2, I'd like to increase the capacity of the crosscut sled slightly. And 3, I'm doing it for you guys. How else can I introduce you to possibly one of the best crosscut sleds man can make? I'm going to take you over to the bandsaw, the table saw, and I'll show you how I get the base onto the runners. Getting the base on the sliders is quite simple. First, I reference one of the edges of the base against my table saw fence. That will keep the base square on the table saw top. I've marked the dimensions of the base, front and back, using some masking tape, and I've also marked the position of where the fence is going to be. Now, the reason why I'm doing all of that is so that I know where to place the sliders. And the fence in particular I am marking because I don't want any parts of the slider to be below the fence. That will provide me with more options to attach the fence to the base. You may notice that the fence is on the opposite side of what you may be used to as far as traditional crosscut sleds go, and that is the secret to the version I'm showing you to make today. Also, the position of the table saw fence is relatively important, and you'll notice that I've positioned it just past the blade. Once I've got the sliders installed, I will take the fence off to one side and I'll trim the base using the fence as, the sliders in the miter slot as my reference, and that will ensure that at least this edge is square to my blade, and that will simplify the process of installing the fence square. To bring the sliders in, you'll notice that I've got washers at the bottom of the miter slot, and my miter slot, or the miter slot on the table saw, is standard 3/4 of an inch. It's ironic that in South Africa, where we use metric, that our miter slots are standard 3/4 of an inch, or at least what is considered standard traditionally. I'll bring that slider up, position the second one where I want it, and then I need to remove the backing. I am using double-sided tape. You probably can use something like CA glue. It's just to attach the sliders to the bottom of the base, which will then allow me to drill holes and attach the sliders using screws. By the way, I am leaving the link to where I found these sliders if you'd like to print a set of your own. I'll leave that link in the description, and for those of you who are interested, I did print them in PETG. You get the backing off. Position the base against the fence, line it up with the marks that I've made, and slowly let it down. Then place pressure on the base. Let's push it out forward, and hopefully the sliders will stay in position. Grab it. And there you go. I will now drill holes, and there's 3 positions in each one of the sliders to use screws to attach it to the base. And you won't believe me that it's now my 4th take trying to get both sliders come out at the same time. I'll install the screws and I'll bring you back when I trim the edge. With the sliders mounted to the bottom of the base, next we trim this corner or this edge. Set the depth of the cut. Fence remains out of the way. And now we're simply going to be using the sliders as our reference. After we've trimmed the edge, that should now be parallel with the blade, assuming that my miter slot is parallel to the blade. I have a handy little homemade jig that I use, a dial indicator, to do that particular alignment. If you'd like to see me do that or want me to show you how to do that, drop me a note in the comments section. But with that trim done, I'm going to take you back to the workbench and we start installing the fence. Getting the fence onto the base and square to your reference edge that you get, so that you get a square cut when using the Crosscut Sled, is probably the hardest part of this whole build process. And that is where the back and forth can come in, where you install the fence, do a test, it's not square, and you have to go back, do adjustments. Typically what is used for doing that, or get it very accurate, is what is called the 5-cut method. And if you Google that, you'll find all the necessary information that you'll need on that. Of course, the amount of back and forth is also somewhat determined by your level of, shall we say, perfectionism. I do not attach the fence to the base using glue. I drive screws through the base and into the fence, and that allows me some level of adjustability going forward. Of course, I need to know where to drill those holes, and how I do that is I turn the base upside down, line the fence up with the edge where I will be installing it. Remember, you need to choose the right edge. Line it up roughly, and then I strike a line along the fence, and that gives me some idea of where I need to position the holes. I've already done that in a previous take. What I'll do then is I'll drill a hole on the corner where the reference edge meets the back edge of where the fence will be, another one in the middle, and another one on the opposing corner. Already installed here and driven a screw through the base into the fence. We'll now be setting the fence square to our reference edge. Get our reference square. Slowly slide up the square so that it references up against your fence. Adjust the fence so that it sits flush against the blade of your square. Happy with where that is. Now very gently clamp everything together so that you can drive the other 2 screws. And do that off the edge of the workbench. Don't over tighten from the start. Just gently get everything together before applying final pressure. Try and position the clamps in such a way that you can get access to the screws. Gently tighten everything down, and before we continue we check that the fence has stayed put, and it seems like it has. Turn the whole assembly around and screw in the final 2 screws. Remove the clamps, and before you do your test cuts, make sure everything remains in position. Perfect. At least I hope it is. And now we're going to go over to the table saw, and I'll do a test cut, show you what we are looking for, and I'll show you how to use this little jig. On to the moment of truth and our first test cut. Not exactly. I took a sneaky test cut before I started filming this section, and I'm quite happy to report that the accuracy after the initial setup is very close, or if not within specification, or at least where I like to have it as far as accuracy goes. I can spend a lot of time dialing it in to perfection, but honestly I'd rather use the last few minutes that I have with you today and show you 2 other improvements that I'm going to make to this sled to make it even better. But back to the test cut. I can, as I mentioned, spend a lot of time to adjust it to perfection, and if I make it sound like it's hard, I do apologize, it isn't, but it does take a lot of time, but not particularly hard. What I do want to do though is also run through how you use the sled, and maybe show you 1 or 2 things that you need to pay attention to when you decide to build one of these. To do so, I am going to make a cut on a test workpiece. Back to the test, excuse me. When you are making your test cuts, I use the same square that I used to set up the fence. Make sure that you reference the square against the edge that was against the fence. Lift it up to the light and then have a look and see how accurately you've worked. Also, your test piece needs to be relatively wide when you're doing the testing. You may have a very small inaccuracy in your initial settings, and it may be very small here, but as you move further away from the pivot point, that inaccuracy compounds and becomes easier to see the further you are away from the fence. So don't use a very narrow workpiece. It may look perfect, and then eventually you do realize that your adjustments needed to do some, or have some more work done. I am going to do a cut quickly, and I'd like you to pay attention to how I go about doing that. As I made the cuts, I hope you paid attention to how I used my hands to keep the workpiece under control. On a traditional crosscut sled that you may have seen out there or even made yourself, is typically you have a fence on this side of the sled and then again on the back of the sled, and your workpiece will register on the fence on this side. Because of the way that your saw blade turns, it will be towards you, and that pushes the workpiece into the fence. And using a fence in that, or a crosscut sled in that style, you typically only really need to keep your workpiece under control and pay attention to where your hands are, so that when the blade comes through the fence, your hands are not in the way. In this case, because of that pressure on your workpiece, you have to place constant pressure on your workpiece and push it into the fence, and I'm using this hand to keep it down. To some extent, the height of the fence is determined by this action, and if your fence is too high and you struggle to get your hand down here, it can be a problem. Partially, the height of the fence that I've got it set here is to be able to install the stops that I'm going to be showing you in a minute. Because I'm constantly paying attention, as you should be doing using any power tool, having my hands involved, I'm constantly watching the cut, and I am all the time aware of where the blade is in relation to my hands. Whereas if you use a crosscut sled where the fence is in the back, what may happen is the blade may come through the fence and it can nick you if you are not paying attention. There are various ways that you can mitigate that, but in this case I don't need to do that. Now, I did mention earlier that this crosscut sled punches way above its weight class as far as capacity goes. Again, if you have what I'm now calling a traditional crosscut sled, is you have the fence there, you have the fence in the back, and your capacity is determined by the space between them. In this case, it's not so. Of course, my workpiece will be registered against the fence. My capacity starts the moment my blade enters into the cut, and it goes all the way to the point where I am exiting the cut, and I remain in control of the workpiece during the cut. And I can go as far as where the slider is engaged, and that will give me accuracy. So as you can see, that the capacity of the workpieces that you can process on a sled like this far exceeds its actual physical footprint, and that's one of the main reasons why I absolutely love this style of crosscut fence. So after a successful test, I'm going to do two improvements, or show you two improvements that I am going to add to this before we are done. The stop and T-track system is the first of two additions that I am going to be making to this crosscut sled. I do want to show you one or two design considerations. The first is the height of the fence. When I flip the stop down, I want the bottom of the stop to be close to the upper surface of the base, and that to some extent then determines the height of the fence. Also, as I mentioned earlier, you don't want the fence too high to allow your one hand to be able to control the cut and keep your workpiece down. So no real measurements, just eyeballing the heights so that I have the stop in the correct position. The next is, as I flip the stop down, I want this surface here to be flush or completely against or flat against the surface of the fence. By flipping it down and moving the track back, you can see that the track is a little bit back from the edge of the fence, and naturally you would want to move the track so that it is flush with the fence, and I find that the stops work better when they are flush against the surface of the fence rather than the track being forward. Apart from cutting this T-track to length, drilling a couple of holes, there's really not much to it. You may see that I have a ruler placed or stuck to the upper surface of the T-track. I never use it, and I manually measure the distances of the repeat cuts or the sizes that I'd like to cut. The next addition I am going to show you is something that I've been wanting to do for a very long time, and I'm hoping that it would improve the cut quality of not only this fence but one of my other sleds as well. So I'll bring you back to show you how I do that one. And we head into the final stretch of today's build, and this one involves the smaller section of plywood I showed you at the beginning of the video. To this I added a slider, this time cut from a small section of hardwood, and I installed it exactly the same way as I did for the crosscut sled. However, this time I did so on the other side of the blade. Now I have a support platform that will catch any offcuts before they drop down to the table saw top. I found on my previous sled that when that happened, I sometimes got tear out on the corners, and my test cut seems to indicate that that problem is now completely solved. Added to this, because I trimmed the edge on the sled as well as on the platform, I effectively have a zero clearance insert, and honestly it's an update that I should have done a long time ago. I can also use the platform on the other side of the table saw, and there it provides support for another sled in my arsenal, and I'll leave a link at the end of the video where you can go and check that out for interest. Not too shabby for 15 minutes worth of work. That does bring us to the end of today's video. As always, thank you so much for joining me in my workshop. And before I leave you, as a reminder, remember, complicated isn't always better. Until I see you next time, I hope you have a good one. Cheers.